Hello students, I hope you will be fine. This is Zaki and I am your physics teacher. Today I will teach you the next part of in this chapter, and the chapter name is current electricity. The next part is electric current and power. In previous class we have studied that what is electric current. Now electric current is defined as the charge per unit time, that is called electric current, and we can also say that according to the Ohm's law, I is equal to V upon R, that is voltage per unit resistance, are called current. Okay, today I will teach you in briefly explain that is the electric energy and power. Okay, let's start. Now we know that I is equal to Q upon T, that is I is equal to Q upon T means charge per unit times. Okay, now Q is equal to IT, Q is equal to IT. Okay, in previous class we also know that in previous class we have studied that the voltage, that is potential difference, are also defined as the work done per unit charge. The potential difference is defined as the work done per unit charge, that is V is equal to W upon Q. That is V is equal to W upon Q. Now W is equal to V into Q. W is equal to V into Q. Okay, according to the Ohm's law, according to the Ohm's law, V is equal to IR. V is equal to IR. Now this is the equation first. Put the value of V is equal to IR in this equation. Now we get, put the value of V in equation first. We get that is W is equal to VQ. Now V is equal to IR into Q, that is W is equal to IR into Q. Okay, we also know that Q is equal to IT. To put the value of Q in this equation, that is IR into IT, that is W is equal to I square RT. W is equal to I square RT. Okay, now we also know that I is equal to VR according to the Ohm's law. Then put the value of I in this equation. Then we get, that is W is equal to I square RT. Therefore, I is equal to V upon R. That is I is equal to V upon R. Now, the W is equal to V square upon R square into R into T. That is cancel out to each other. W is equal to V square R into T. This is also the relation of work done. W is equal to V square R into T. That is, this is the first relation. W is equal to I square RT. This is also the relation of work done. W is equal to IR into Q. Okay. Now note down this relation. Now, in case of heating appliances, that is electric heater, room heater. Now the W is equal to H. That is, the final relation is I square RT and the V square R into T. That is, in heating appliances, work done are also equal to H. That is, H is equal to I square RT are also equal to V square upon R into T. Okay, note down. Okay, got it? Got it? Okay. In previous class, I have studied that what is the SI unit of work done. What is the SI unit of work done? Now, its SI unit is joule. Its SI unit is joule, and the symbol is J, and the symbol is J. Okay. Now, what is power and the interrelation between power, voltage, current and resistance? Okay. Now, what is power? What is power and the interrelation between power, voltage, current and resistance. Power, voltage, resistance and current. Okay. Now we know that power is equal to work done per unit time. That is, power is equal to work done per unit time. Okay. Now we also know that W is equal to P is equal to W is equal to voltage into charge upon time. That is, W is equal to QV. है ना? Okay. Now we also know that V is equal to IR. V is equal to IR. That is, V is equal to IR according to the Ohm's law. I into R into Q upon T, and we also know that Q is equal to IT. Q is equal to IT, that is, P is equal to IR into IT upon T, that is, T and T are cut to each other. Then what is the relation between this? What is the relation between this? Now P is equal to I square R. This is the relation of power, current and resistance. Now we also know that I is equal to V upon R. I is equal to V upon R. Put the value of I in this equation, that is V square upon R square into R. Cancel out to each other. P is equal to V square upon R. This is also the relation of the power between voltage, resistance, and this is the relation between power, current and resistance. In the beginning, we can say what is power and the interrelation between power, voltage, current and resistance. Okay. Now its SI unit is the combined form. Its combined form, that is, P is equal to I square R are also equal to V square upon R. Okay. Okay. Its SI unit is what? Its SI unit is what? And the symbol is W. And the symbol is W. Okay. Note down. Commercial unit of electric energy. Commercial unit of electric energy. Now What is commercial unit of electric energy? Commercial unit of electric energy. Commercial unit of electric energy, uh, that is P is equal to VI, that is power is equal to voltage into current, that is watt is equal to 1 volt into 1 ampere, 1 volt into 1 ampere. Okay, the bigger unit of uh, the bigger unit is bigger unit bigger unit of power bigger unit of power, that is 1 kilowatt, 1 kilowatt, that is 10 to the power 3 watt. 1 kilowatt hour is equal to 10 to the power 3 watt, and the 1 megawatt 1 megawatt are equal to 10 to the power 6 watt. 1 megawatt are equal to 10 to the power 6 watt, and the 1 gigawatt are equal to 10 to the power 9 watt. This is the bigger unit of power, that is 1 kilowatt are equal to 10 to the power 3 watt, 1 megawatt are equal to 10 to the power 6 watt, and the 1 gigawatt are equal to 10 to the power 9 watt. Okay, now note down this. Note down this. नोट कर लिया आप लोगों ने? The question is arise, what is 1 kilowatt hour? Now, what is 1 kilowatt hour? That is 1 kilowatt hour is equal to 1 kilowatt into hour. Okay, 1 kilowatt, that is 1000 watt. 1 kilowatt, that is 1000 watt into R is equal to, okay, there are 60 minutes in 1 hour. There are 60 minutes in 1 hour. That is, in 1 minute are also equal to 60 seconds. That is 3600 seconds in 1 hour. Okay. Now the 36 into 10 to the power 5, that is 3.6 into 10 to the power 6 joule, because 1000 watt, that is joule per second, and the 3600 second, that is seconds a second, are cancelled out to each other. That is, the final is 3.6 into 10 to the power 6 joule. Now how many energy are consumed in 1 kilowatt hour? The answer is 3.6 into 10 to the power 6 joule. Okay, note down this relation. Note down this relation. Now the household consumption of electric energy. Household consumption of electric energy. Household consumption. Household consumption of electric energy. Household consumption of electric energy. Let us consider one heating appliances. It is a 1 kilowatt. Okay, they are using in 2 hours constantly. That is 1 kilowatt are using 1 kilowatt are using in 2 hours. That is total is 2 kilowatt hour. 2 kilowatt hour. Okay, 2 kilowatt hour are using in one day. 2 kilowatt hour are using in one day. Let us consider that is in a month there are 30 days in a month. In a month, that is 30 days. 2 kilowatt hour in one day, एक दिन में. Okay, in a month that is 30 days. Now 2 into 30, that is 60 kilowatt hour. That is 60 kilowatt hour in a 1 month. They are using a 60 kilowatt hour in 1 month. Now the 1 unit is, let us consider 5 rupees are charged in 1 unit. 5 rupees are charged in 1 unit. That is 5 rupees charge in 1 unit. Then 60 into 5 is equal to 300 rupees. Let us consider 1 kilowatt hour are using in 2 hours in a day. That is 2 kilowatt hour in 1 day. In a month, that is 30 days. Now 2 into 30 is equal to 60 kilowatt hour. The rupees 5 charge in 1 unit. Then 60 into 5 are is equal to 300 rupees are charged in a month for 60 kilowatt hour. Okay, students, note down. The next class I have studied that I have teach the next part of in this chapter. Okay, so goodbye.